Hello friends and welcome back to my channel. Today I will present you a simple but yet interesting project. I will show you how to make an electronic dice simulator using an Arduino. Before we start, I would like to invite you to subscribe to my channel and also to activate the notification bell in order to stay updated on upcoming videos. Let's get started. For this project we will need a 7 segments display, some resistors, a push button, a prototyping breadboard, some jumper wires, and obviously an Arduino. In this case I'm going to use an Arduino Nano, but you can use any other models as well. For example, the Uno or the Mega. Before we start, I would like to spend some words about 7 segments displays. These devices have been around for a very long time, but they are still widely used because they give a pretty technological look to DIY projects. So let's see how they work. As their name suggests, these displays are made of 7 segments, labeled with letters from A to G. In addition, they can have a point representing the decimal separator. This is called DP, or decimal point. Internally, the segments are made by simple LEDs that can be properly turned on or off, in order to obtain the digits from 0 to 9. 7 segments display can be of 2 types, depending on their internal electrical connections. In common anode models, the anodes of all LEDs are connected together. The common terminal is connected to the positive rail, and every segment can be turned on by connecting its cathode to ground by means of a limiting resistor, as you can see in the video. In common cathode models, the cathode of all LEDs are connected together. In this case, the common terminal is connected to the negative rail, and every segment can be turned on by connecting its anode to the positive rail. On the back of the display there are 10 pins. In this image you can see how they are internally connected. Now that we are familiar with the 7 segments display, we can proceed with our project. Here we can see all the components placed on the breadboard. In addition to the Arduino and the display, we have 7 resistors, each one of 330 ohms, and a normally open push button. The first thing to do is to connect the power rails on the sides of the breadboard to the GND and 5V lines of the Arduino. Now we can power the display through its central pins. The model I'm using is a common anode, so I connect the central pins to the positive rails. If you use a common cathode model, the central pins must be connected to the GND rail. In addition, you will have to do a little modification in the sketch. Now, the pins corresponding to the 7 segments must be connected through the limiting resistor to 7 pins of the Arduino. For the right connection, follow the schematics shown in the figure. The connections of the push button are very simple. One pin goes to GND, while the other one must be connected to pin D12 of the Arduino. The total connection seems a little bit complicated, but with some attention you can easily set them up. And here is how I made my prototype. For the connections, I've used single core wires cut to measure, instead of the common jumpers, in order to obtain a more compact result. Now the last thing to do is to load the appropriate firmware. In the video description you can find the link to the download page. If you followed my schematic for the connections, the circuit should work as is immediately. If you are using a common cathode display, you have to modify the sketch as follows. Comment out the first line, adding 2/ at the beginning of the line, and decomment the second one, removing the slashes. Remember that in this case, the common pin of the display has to be connected to the negative rail. By modifying these lines, you can change the minimum and maximum numbers displayed by the circuit. You can leave this to 1 and 6 if you want to simulate a real dice, otherwise change it according to your specific needs. If you connected the display or the push button to different pins respect to my schematic, you have to modify these lines accordingly. Now I'll load the firmware, and here it is, a nice electronic dice. In the video it seems that there is not a great contrast, but in reality the display is of a beautiful bright red, and the effect is very nice. Well, that's all for this video. Please let me know in the comments if you found it useful, and don't forget to subscribe if you like my channel. For the moment I greet you all and I wait you for my next projects. See you soon!